In today's lesson, we are still reviewing the AS Physics. I will discuss Paper 2, AS Level Structured Questions from March 19, Question Paper 2-2. Number 1. The ampere, meter, and second are SI base units. State 2 other SI base units. We have 7 base units, and I will just mention here kilogram and Kelvin. Actually, we still have 2 more, which is candela and mole. The average drift speed v of electrons moving through a metal conductor is given by the equation V equals mu F over E, where mu is a constant, E is the charge on an electron, and F is the force acting on the electron. We want to determine the SI base units of mu, so we will rearrange this equation. So we'll get mu equals V E over F, and the SI base unit for V is meter per second. For E is charge. Charge Q is equal I times T, so the base unit for E is ampere second, and F is in the unit of Newton. The base unit of Newton is kilogram meter per second squared. So when we want to find the base unit of mu, it will be meter per second multiplied by ampere second divided by kilogram meter per second squared. So we will cross M out, and also s to the power of minus 1, and s can also be crossed out. So we will have s squared multiplied by a divided by kilogram, or you can write it down as s squared a kilogram to the power of minus 1. Number 2, A, define displacement. Displacement is distance in specified direction, and acceleration is the rate of change of velocity. 2B, a man wearing a wingsuit glides through the air with a constant velocity of 47 meters per second at an angle of 24 degrees to the horizontal. The path of the man is shown in this figure. Given the mass, total mass of the man and the wingsuit, and also the time taken to glide from point A to point B. It is 2.8 minutes. The first question, with reference to the motion of the man, state and explain whether he is in equilibrium. We should see this statement that he is gliding through the air with a constant velocity. So when it is a constant velocity, he is in equilibrium. Yeah, so because constant velocity means that there is no resultant force. So he is in equilibrium. Show that the difference in height h between points A and B is 3,200 meters. So we want to find this height. We can see this triangle, and you can use the sine of 24 degrees equals h over AB. So first we have to find the value of AB. AB itself is the distance taken by the man. He is moving at constant velocity of 47 meters per second, and from A to B it takes 2.8 minutes. So the distance AB will be 47 multiplied by the distance taken, 2.8 minutes multiplied by 60 seconds per minute. So you'll have AB equals 7,896 meters. So we use the sine of 24 degrees equals h over AB, and h will be equal to AB times the sine of 24 degrees. And I have calculated that this is 3,200 meters into significant figures. For the movement of the man from A to B, determine the decrease in gravitational potential energy. We know that the decrease in gravitational potential energy, delta potential energy, is mass times g times delta h. The mass is given 85, g is 9.81, and delta h is 3,200 meters. So you can find delta potential energy, which is 2.7 times 10 to the 6 joules. The magnitude of the force on the man due to air resistance. We can use this potential energy, knowing that the decrease in gravitational potential energy is equal to the work done by the man. So the work done is F times D. We want to find the value of F, which is the work done, this one, divided by the distance taken. It is 340 newtons. Or you can use the diagram of force here. The man has a certain weight, and this weight can be resolved into weight times the sine of 24 degrees on x-axis, and the vertical component will be weight times the cosine of 24 degrees. Because he is moving at constant velocity, so we know that the resultant of force equals 0. So the force due to the air resistance will be equal to the horizontal component of weight, or weight times the sine of 24 degrees, as we see in the diagram before. So the force due to the air resistance is 85 multiplied by 9.81 multiplied by the sine of 24 degrees. It is equal to 340 Newton. The pressure of the still air at A is 63 kilopascals and at B is 92 kilopascals. Assume the density of the air is constant between A and B. Determine the density of the air between A and B. We use the hydrostatic pressure equation. P equals rho GH, so delta pressure will be equal to rho times G times delta height. Delta P is 92 kilopascals minus 63 kilopascals equals rho times G 9.81 times delta H was 3,200. So we can calculate here that the rho, the density of air, is 0.92 kilogram per meter cube. Number 3, two balls X and Y move along a horizontal frictionless surface as illustrated in figure 3.1. Ball X has initial velocity of 3 meters per second in a direction along line AB. Ball Y has mass of 2.5 kilograms and an initial velocity of 9.6 meters per second in a direction at an angle of 60 degrees to line AB, or to the horizontal. The two balls collide at point B. The balls stick together and then travel along the horizontal surface in a direction at right angles to the line AB with the same velocity v, as shown in figure 3.2. First, I would like to resolve this velocity factor into x component, which is 9.6 times the cosine of 60 degrees, and the y component to be 9.6 times the sine of 60 degrees. In the next question, by considering the components of momentum in the direction from A to B, show that ball X has mass of 4 kilograms. We will see the x components of momentum. So the total momentum on x-axis will be equal to 0. And then mx vx plus my vy equals mx vx prime plus my vy prime. This is the conservation of momentum. Mx multiplied by vx is 3 meters per second plus my multiplied by vy. Vy is this. On x-axis, it is 9.6 times the cosine of 60 degrees, but it will be given negative sign because it moves in opposite direction to the direction of x. Equals mx vx prime plus my vy prime. We know that there is no x and y component of velocity after the collision, so this will be equal to 0. So we can calculate that mx is 4 kilograms by paying attention to the x component of the momentum. And for B, calculate the common speed v of the two balls after the collision. Now we have to pay attention to the y-axis. Because after the collision, both balls move together with the same velocity, the common speed, capital V. Yeah, so we use the conservation of momentum, mx vx. This is 0 because initially there is no vertical component of velocity of x. So there is no vertical component of momentum of x. So mx vx will be equal to 0. But there is a vertical component of momentum of ball y. So this is mass times the y component of velocity, 9.6 times the sine of 60 degrees. It should be equal to mx times v after the collision. After the collision, vx prime on y-axis is v, and for y, the mass is 2.5, and after the collision, it moves with the same velocity v. So we have now 6 0.5 V should be equal to 20.785. I have calculated this. Then V is equal to 3.2 meter per second. So they both move with the same velocity, 3.2 meter per second. This is called the inelastic collision. After the collision, both objects move together with the same speed. Determine the difference between the initial kinetic energy of ball X and the initial kinetic energy of ball Y. We know that kinetic energy is equal to a half mv squared, so we'll have to find the difference. Difference in kinetic energy will be a half times my vy squared minus a half times mx vx squared. So it is equal to 97 joules. Number 4. A. Define electric field strength. Electric field strength is force per unit positive charge. And B. Two very small metal spheres X and Y are connected by an insulating rod of length 72 millimeters. A side view of this arrangement is shown in figure 4.1. We have a uniform electric field. The field strength is 5 times 10 to the 4 volt per meter in vertically upwards direction. And the sphere X has a charge of positive 3e, and sphere Y has a charge of minus 3e. E is the elementary charge. And then the electric field is produced by applying a potential difference of 4 kilovolts between two charged parallel metal plates. We want to calculate the separation between the plates, given the E, the electric field strength, and the potential difference. So we can use this equation, E equals V over D. D is the separation between the plates. So when we want to find D, we'll just have to divide the V, 4 kilovolts, divided by the D, 5 times 10 to the 4. So it will be equal to 8 times 10 to the minus 2 meter. The second question, describe the arrangement of the two plates. Include in your answer a statement of the sign of the charge of each plate, and we can draw on figure 4.1. I would like to draw it here. We see here that the uniform electric field with the certain field strength is in the direction of vertically upwards, and we know that electric field is directed from the positive plate to the negative plate. So I can draw this like I can draw the plates like this. This one is the positively charged plate, and this one is the negatively charged plate. They are both horizontal, and the rod is placed between those two charged parallel metal plates. Determine the magnitude and the direction of the force on sphere Y. The magnitude we can calculate using this equation, F equals Q multiplied by E, because the definition of E itself, electric field, is force per unit charge. So F is 3 times the elementary charge, 1.6 times 10 to the minus 19, multiplied by the E given, 5 times 10 to the minus 4. So it is 2.4 times 10 to the minus 14 newtons. And the direction of the electric force experienced by a negative charge, because sphere Y is a negatively charged particle, it will be opposite to the direction of the field. So if the direction of the field is upwards, then the direction of the electric force experienced by a negative charge will be downwards. The electric forces acting on the two spheres form a couple. This couple acts on the rod with a torque of 6.2 times 10 to the minus 16 Newton meter. So this charge will experience a force downwards because it is negatively charged. This charge will experience a force upwards, and those two forces will create torque on the rod. And we are given the torque of a couple. We want to calculate the angle theta of the rod to the horizontal, so we can use the equation of the torque of a couple equals F times D, and D here is the perpendicular distance here. So if you want to find this, you can use torque equals F multiplied by 7.2 times 10 to the minus 3 meters multiplied by the cosine of theta. So you can find that theta is 69 degrees. Number 5, by reference to two waves, state the principle of superposition. Superposition of two waves when two waves overlap at a point and the resultant displacement is the sum of the individual displacements. And state what is meant by coherence. Coherence means constant phase difference between the waves. Now we have two coherent waves, P and Q, meet at a point in phase and superpose. Wave P has an amplitude of 1.5 centimeters and intensity I. The resultant intensity at the point where the waves meet is 3I. We want to calculate the amplitude of a wave Q. We know that intensity is proportional to amplitude square. So we can use comparison between two conditions here, that 3I divided by I should be equal to, here, the resultant intensity. So the resultant intensity must be amplitude plus 1.5 centimeters squared divided by the initial amplitude is 1.5 centimeter squared. Yeah, so you can cross I out here and you can find the value of amplitude, which is 1.1 centimeters. The apparatus shown in figure 5.1 is used to produce an interference pattern on a screen. Light of wavelength 680 Newton meter is incident on a double slit. The slit separation is A. The separation between adjacent fringes is X. Fringes are viewed on a screen at distance capital D from the double slit. Now, distance D is varied from 2 to 3.5 meters. The variation is shown in this figure. Use this figure to determine the slit separation A. The equation for this is lambda equals AX over D, and we are using wavelength of 680 nanometers. So when you want to find A, it will be equal to lambda multiplied by D divided by X. And I can just take one value. I will take where D is 3 meters, and that's where X is 6 millimeters. So I can use that value here. So I can calculate A using that. Or you can also find the gradient of the graph, which is X over D, and you use 1 over gradient. That will be okay. Yeah, I will just take one value here. D is 3 meters, X is 6 times 10 to the minus 3 meters. The lambda is what has been given. So A is 3.4 times 10 to the minus 4 meters. Now, the laser is now replaced by another laser that emits light of a shorter wavelength. On figure 5.2, sketch a possible line to show the variation with D of X for the fringes that are now produced. We can use this equation, lambda is equal to AX over D. And when there is shorter wavelength, we use shorter wavelength, X over D is smaller. So it will result in the gradient of the graph that we will draw will be smaller. And then for the same value of D with shorter wavelength, when D is smaller, when D is the same value, lambda is shorter, A stays the same, X will also be smaller. So that will result in our graph to be below the old line. So if this is the old line and this is X against D graph, the gradient must be smaller and it should be below old line. So you can draw about like this. Yeah, the gradient is smaller and it will always be below the old line. Number 6. Using energy transformations, describe the EMF of a battery and the PD across a resistor. You can use the definition that EMF is the energy transferred from chemical to electrical energy per unit charge, while PD is the energy transferred from electrical to thermal energy per unit charge. B. A battery of EMF 6 volts and negligible internal resistance is connected to a network of resistors and a voltmeter as shown in figure 6.1. Resistor Y has a resistance of 24 ohms and resistor Z has a resistance of 32 ohms. The resistance Rx of the variable resistor X is adjusted until the voltmeter reads 4.8 volts. We want to calculate the current in resistor Z here. Yeah, so here we can see that the voltmeter, this voltmeter reads 4.8 volts. It will measure the potential difference between Z. Yeah, so when you want to find the current in resistor Z, you can use I equals V over R. This V is that 4.8 volts. What is written, or what we can read from the voltmeter, and that R is 32 ohms. So the current flowing here is 0.15 amps. The total power provided by the battery, you can just use this 6 volt multiplied by the current flowing, because P is equal to V times I. Yeah, you can also use the other equations, I squared times R or V squared over R, but I'm going to use this one because this is the easiest. 6 multiplied by the current flowing, it is 0.9 watts. The next question, we want to find the number of conduction electrons that move through the battery in a time interval of 25 seconds. We can use this equation Q equals I times T. It is equal to 0.15 multiplied by 25 or 3.75 coulombs. And the number of electrons is this value of charge divided by the elementary charge, 1.6 times 10 to the minus 19. So it is equal to 2.3 times 10 to the 19 electrons. The next question, we want to find the total resistance of X and Y connected in parallel. We can see here that the total EMF is 6 volts and this Z gets 4.8 volts. So we can find Vxy, which is equal to 6 volts minus 4.8 volts. It is equal to 1.2 volts. So Rxy will be equal to the V of xy divided by the current flowing. The current flowing will be 0.15. So Rxy will be 8 ohms. And the next question is we want to find the resistance Rx. We know that X and Y, they are connected in parallel. So 1 over 24 plus 1 over R of X should be equal to 1 over 8, the total R of XY. So you can calculate Rx to be 12 ohms. The resistance Rx is now decreased. State and explain the change, if any, to the reading on the voltmeter. When the total resistance, when the Rx is decreased, then the total resistance will decrease. So the reading on the voltmeter increases. Number 7, last number, the names of 4 particles are listed below. We have alpha, beta plus, neutron, and proton. State the names of the particles in this list that are not fundamental. They are alpha, neutron, and proton. They are not fundamental. That do not experience an electric force when situated in an electric field. Of course, it will be neutron because it is neutral, does not have any charge, and has the largest ratio of charge to mass. It is beta plus. A hadron has a charge of positive E, where E is the elementary charge. The hadron is composed of only 2 quarks. One of these quarks is anti-down quark. By considering charge, state and explain the name or the flavor of the other quark. The charge of this anti-down is equal to positive 1/3 E. So the charge of the other quark will be 1E minus 1/3 E will be equal to plus 2 over 3 E, and this will be up quark. Yeah, the flavor is up. Okay, that's all. I hope this discussion is useful for you. Please prepare for tomorrow's quiz. Thank you.